Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. The topic of this lecture is important questions of representation of data. For this lecture, I am using the work of one of my best student, Miss Uneza Alam of class 2019, the Lyceum. An important advice for me and for everyone: be of benefit to others. Stem plot and box plot. Example: a random sample of 25 people recorded the number of glasses. This means the unit, number of glasses of water. They drink in a particular week. The results are shown below. Draw a stem and leaf diagram to represent the data. Now, how will you draw the stem plot? Number one, make these two lines, horizontal and vertical. Here we write stem and here we write leaf. Now observe the smallest and largest observation of this data. So the smallest observation is, I think, 14, and the largest observation is 47, I guess. So you should write 1 here, 2, 3, 4. Now cancel the first observation. It's 23, write 3 here, and you will read this thing as 23. Cancel this second observation, write here. Then 32, 2 should be in the column of 3. 14, 4 should be here. Then 25, then 22, 26 should be in the column of 2. 36, 6 should be here. 45, 42, 47, 28, 17, 38, 15, 46, 18, 26, 22, 41, 19, 9 must be here, 21, 1 should be here, 28, 8 must be here, 4 should be here, and 30. This is the way to draw this stem plot. But you have to arrange the numbers in ascending order, and this is the fastest way. So first write the numbers. Let's suppose here you can write the numbers at anywhere. 4, 7, 5, 8, 9. Then the second row is 1, 2, 2, 3, 4, 5, 6, 6, 8, 8. 5, 6, 6, 8, 8. I'm writing the numbers here. 4, 7, 5, 8, 9. 1, 2, 2, 3, 4, 5, 6. 6 is twice. and 8 is also twice. The next row is 0, 2, 6, 8. Then 1, 2, 5, 7. Sorry, 1, 2, 5, 6, 7. 0, 2, 6, 8. 1, 2, 5, 6, 7. Yeah, I guess 7. 47. Yeah, exactly. That's fine. Please follow this method which I just use and write the totals here. 1, 2, 3, 4, 5, 6. 6 numbers are here. 10 are here. 4, 5, and the total is 25. The total must be match 25. Write the key. You can write any number. I wrote this one. 2/1 means 21 glasses of water. A unit is here. Make sure you must write the unit. Now the minimum observation. Now the second part is on graph paper, draw a box and whisker plot to represent data. For that we must have 5 informations, 5 important informations. Minimum observation, maximum observation, median, Q1, Q3. I already have discussed how to get median and quartiles in my first lecture of this chapter, representation of data. So for median, we use this formula. I'm just writing the formulas here. Make sure you have watched my first lecture on this chapter. This is the formula for median, whether n is even or odd. No, you should use this formula. The same formula is used for both. Q1. Since n is odd, so the formula of Q1 is 1 upon 4 n plus 1th observation. Q3, the formula is 3 upon 4 n plus 1th observation. So basically we use these formulas here. See, if you would substitute 25 here, then you will get 13th observation. So 13th observation is this one. 6, 7, 8, 9, 10, 11, 12, 13. This is the 13th observation. So median is 26. When you will put 25 here, you will get, I think, 6.5th observation. 6.5th means the average of 6th and 7th observation. So the answer should be 20. And this must be 19.5th, I guess. 19.5th observation. So till here we have 16, 17, 18, 19, 20. So take the average of these two. 37. And use pencil for diagrams. Now box plot. For box plot, use the graph horizontally, graph paper horizontally, but now you will get the printed graph on the answer sheet. So you have to use the printed graph as it is. So this is on graph paper, but now we get questions, we get grid on the printed answer sheet. So you should use the graph, that grid as it is. And since graph is printed on the answer sheet, therefore this axis must be here. Make sure you will draw this axis here. And must write the unit, number of glasses, must label this horizontal axis. I already have explained how to draw a box plot in my first lecture, but I'm again going to explain how to draw a box plot. Well, number one, you have to draw the horizontal axis and label the axis. And number 2, you have to mark the minimum observation from 3 centimeter to this horizontal line. This distance is 3 centimeter, and this is the minimum observation, which is, I guess, 14. Yeah. Then we have Q1, which is 20. This is Q1. This is the minimum observation. This is Q1, this is median, this is Q3, and this is the highest observation. First mark all these observations and then make the box. And the width of box should be at least 2 centimeter. And the length of this whisker should be of 1 centimeter or 2 centimeter. I usually draw it of 1 centimeter. I keep this length as 1 centimeter. You can keep this at 2 centimeter if you want. And make sure these whiskers must not enter the box. If these whiskers would enter the box, you will lose marks. So this is the box plot. If I ask you comment on the distribution, then you would say, since Q2 is close to Q1, since median is close to Q1, therefore this box gives an immediate impression of a positively skewed distribution. Sorry. So this is the way to draw a simple stem plot, and this is the way to draw the box plot. Now I'm going to take the question of stem plot, another question of stem plot, but that question would be, okay, first discuss this question. Let's discuss this question, and then I will take a question of back-to-back stem plot question. Now, again, we have to draw this stem plot. First, observe the smallest observation, which is 2, and the largest observation is 35. So you can read this 2 as 0, 2. So write 0, 1, 2, 3. And here we have you know how to draw the stem plot, so you can do this yourself. This should be in ascending order, and you have to write the key. And here we have number of people traveling on a certain bus, number of people. So this is the key, number of people, the unit for the key. So 1/2 means 12 people. For median, use this formula, n plus 1 upon 2th observation. So this is 21, so you'll get 11th observation, and 11th observation is this, so 19. The lower quartile, this is the formula for lower quartile, 1 upon 4 n plus 1th observation. You'll get 5.5. 5.5 means average of 5th and 6th. This is the 5th observation, and this is the 6th observation. Take the average of these two. 3 upon 4 n plus 1, that means 16.5. 16.5 means average of 16 and 17. So till here we have 11, 12, 13, 14, 15, 16, 17. So take the average of these two. IQR is simple, it's Q3 minus Q1. Now state in this case, which of the median and mode is preferable as measure of central tendency, and why? Well, since this data has mode 23 and the total number of observations are 21 and median is 19, median is preferable as it is unaffected by extreme values. The answer of median is 19. If you observe the lowest observation, which is 2, and the highest observation is 35, if you take the average of these two observations, you'll get, I guess, 18.5, and median is close to this number. So, and mode is 23. So median is more preferable as it is unaffected by extreme values. in this case. Now, back-to-back stem plot. This diagram is known as the back-to-back stem plot. In back-to-back stem plot, what we do, number one, observe with the data. It's it's 3 decimal place value or 4-digit number. So for a stem plot, you have to ignore the decimals. Just consider the number without decimal, and you will mention the decimal in the key. Now represent this information and with sugar on the left hand side. So keep sugar here and flour here. So first observe the smallest and highest observation. The smallest is this and largest is this. So you should consider this as 1941. So write 194 here and then 201 till 201. Now for flour, first cancel this observation. 1945, write 5 here. And then 1962, 2 here. For sugar, 1961, 1 is here. 1983, 3 is here, and so on. This should be ascending order in this way, and this should be ascending order in this way. Write the total number of observations, match the total with the given total. And you can write the key, like if you take these two numbers, if you take this number, so you will write this as 1/196/2, and you will read this as 1.961 kg of a bag of sugar, and this 1.962 kg of a bag of flour. And you know how to get the median and interquartile range. Question number 1. A library has many identical shelves. All the shelves are full, and the numbers of books on each shelf in a certain section are summarized by the following stem leaf diagram. All the shelves are full, and the number of books on each shelf in a certain section are summarized by the following stem leaf diagram. Find the number of shelves in this section of the library. You just need to get the total of this number. The total is 67. So there are 67 shelves. Draw a box and whisker plot to represent the data. For that, we must have 5 important informations: the lowest observation, the highest observation, Q1, Q3, median. And you can easily draw the box plot then. If you have all the information, you can draw the box. There is there is no need to draw this interrupted line or jag line. You can directly start your scale from 30. If you want to write this, you can. If you want to make this line, this jag, you can. Otherwise, you can directly start your scale from 30. So it's for your understanding, because some students are used to with jag. So if they want, they can. Otherwise, they can leave this. They can start their scale from 30. Anyway, this is the lowest observation, Q1, Q2, Q3, and highest observation. Next, in another section, all the shelves are full, and the number of books on each shelf are summarized by the following stem and leaf diagram. There are fewer books in this section than in the previous section. State one difference between the books in this section and the books in the previous section. Well, on average, this section has lesser books per shelf. Thus, the books are overall fatter in this section. You can say books are wider. Either books are wider or books are fatter. Because shelves are full. They are saying shelves are full, and there are fewer books in this section. That means either books are fatter or books are wider. Books are placed wider on the shelf. So you can give any 2 reasons. The books are either fatter in this section, or books are placed wider on the shelves. So you can give any reason. Because when books are less and shelves are full, that means either books are fatter or books are placed wider on the shelves. You have to give the reason according to the context. Well, this question is of histogram. You know this. I hope you are used to with this type of table. This is the discrete date frequency distribution. Discrete marks are discrete quantity. Discrete means countable quantity. And we draw histogram and cumulative frequency graph for continuous data. So you have to first convert class intervals into class boundaries. You have to make these two same by subtracting 0.5 from this and adding 0.5 into this number. So this will become 0.5, this will become 20.5, 20.5, 30.5 and so on. So these are the class boundaries, and we must have class boundaries to draw the histogram. And for histogram, we also need the frequency density. For frequency density, you know the formula of frequency density is frequency upon class width. So 40 upon 20 will give you frequency density 2. 34 upon 10 will give you 3.4 and so on. You don't need to draw this table. You can do this directly. You can write frequency density here. Because in exam you don't have much time. This paper is of 1 hour and 15 minutes, so you have to save your time. This student is very smart. She had got world distinction in art math as well, and she had already and she also had got I think second position in Pakistan or Sindh and Balochistan in 3 subjects in CIs. So this student have a lot of time during exam because she practiced a lot. See this, she filled this book. She even did not leave a single question. She did all the questions. This shows this student is really outstanding, hardworking student, an outstanding and hardworking student. So if you have enough practice, then you can draw this table. Otherwise, you should use this table. 5.4, 2.9, and I think this should be 1.4. Yeah, this is here. So a histogram must label the axis, write marks, write frequency density, complete, don't write FD, write complete frequency density. And this scale, horizontal scale is starting from 0.5, so write 0.5 here, and vertical is starting from 0, so write 0 here, and then draw this histogram. So 0.5 to 20.5, the density is 2. So 0.5 to 20.5, 2. Then 20.5, 30.5 is 3.4, and then you should complete the histogram. This is the model class, the highest bar class. So this is the model class, 30.5 to 40.5. So from histogram we can get 2 things. Number 1, we can get the model class, and number 2, we can understand the type of distribution, like if the distribution is positively skewed or negatively skewed. This highest bar is close to lower side, so this is you can say this distribution is approximately positively skewed. And the next part is estimate of mean and standard deviation. Well, this is the formula for mean and this is the formula for standard deviation. We must have mid values. So you know how to get the mid values. Take the average of these 2 numbers or these 2 numbers. It's your choice. So sigma fx, this is f and this is x. So fx, 40 into 10.5, 34 into 25.5 and so on. In variance, make sure you square this number. 40 into 10.5 square, 34 into 25, 25.5 square, and so on, and write the exact value of mean here. This is the estimate, use the exact value. And this is the final answer up to 3 significant figures. I'm sorry. We have done this question. Question number 4 of stem and leaf diagram. The first part of this question is find median and interquartile. I'm leaving this part for you. And the next part is estimate. Now this part is important. We need the values of Q and R, and the IQR is this. The IQR of country Y is this, and we have to estimate the values of Q and R. Find the values. So we will use trial and error method for that. Number one, we have to check what is Q1 and what is Q3. So you know Q1 is 21st observation. Q1 is the 21st observation, and this is the 21st observation. So this information, this observation is Q1. It is 0.82 Q. 0.82 Q. It's here. And then get Q3. Q3 will be this observation. Q3 is 63rd observation, which is this. 0.85 R. It's here. Now see, since in a stem plot is always in ascending order, so the value of Q is either 3 or 4, and the value of R is either 2 or 3. Now you have to use trial and error method. So first suppose Q3. So if Q is 3, then this number will become 0.823, and suppose R is 2, so 0.852. Now take the difference of these two numbers, Q3 minus Q1. If you will get this answer, then these are the right values, 3 and 2. But if you are not getting this answer, then try Q4. So when Q is 4 and R is 2, you will get this number, Q3 minus Q1, 0.028. That means your Q is 4 and R is 2, because you are getting this number. The next part is box plot. You know how to draw the box plot. Now compare the lengths of the insects from the two countries. Well, we have to draw two box plots. Here are the box plots, both the box plots. Write length of insects in centimeter. This is the box for country X, and this is the box for country Y. This distance is 3 centimeter, whereas this distance is 6 centimeter. See, on average, country Y has longer insects than country X, and the range of country Y insects is greater, so you should write lengths are more scattered in country Y. Lengths of insects are more scattered in country Y than in country X. Compare the length of insects from these two countries. Insects in Y are longer than insects on X on average, number one, and greater variation in length of insects in Y. I'm repeating. Median is greater. Median of Y is greater than median of X. So you should say, on average, country Y, the insects of country Y has longer than country X. Insects in Y are longer than in insect in X, and more the range is greater, so more variation in lengths of insects in Y than in X. We have done this question. 6. Histogram is given. We have to complete the table. The area of rectangle is frequency. So this width is 2 and this height is 10. So 10 times 2 makes 20. So you can complete the table in this way. Now estimate mean. This is so simple. Get the mid value and write x here, write t here. Because data is in the form of t. and write t here as well. It's better to write t. So that's the mean. And probability, this is so simple. Two of these students are chosen at random. Find the probability that exactly one takes between 7 and 10 minutes to take a shower. So between 7 and 10 minutes, so between 7 and 10 minutes, there are 60 students. So 60 upon total, and the total is 97. So one is of this range, 7 and 10, and the other is not from this range. So those number of students will be 1 minus 60 upon 97, that is 30 upon 97. And 2 factorial, because this order is, this is random. So when this is random, so write 2 factorial here. You have done probability, you can understand, you can solve this question yourself. I did in this way, a, b, 2 factorial. This is the requirement and this is not the requirement. Or you can say a complement. Well, this thing is very important. This concept is extremely important in representation of data. The concept is frequency, construction of frequency distribution from continuous frequency distribution, from cumulative. Let me correct this. From cumulative. So the concept is construct the construction of frequency distribution from cumulative frequency distribution. Now we have 2 types of data. Number 1 discrete and number 2 continuous. When data is discrete, that is countable, we use class intervals. Remember this thing. When data is discrete, always use class intervals. Always go for class intervals. When data is continuous, then continuous means measurable quantities. We use class boundaries like this. This data is discrete, so we will go for class intervals. We will make class intervals. And now we have possibilities. When upper class boundaries are exclusive, like this thing 90, then the upper limit of the class interval will be 89, one less, because this is exclusive. When this number is inclusive, when the upper class boundaries are inclusive, then then the upper limit of class interval must be same, 90. And then the lower limit of the first class interval must be 1 when this is inclusive. When this is exclusive, then the lower limit of the first class interval must be 0. You have to learn this rule. When upper class boundaries are inclusive, then this number must be same, and the first number of the first class interval, the lower limit of the first class interval must be 1. And when this is exclusive, then this number is 1 less, like this should be 89, and the lower limit of the first class interval must be 0. This rule is for discrete data. Well, when data is continuous, like in these questions 11, 21, 26 and 33, so we will go for class boundaries and we will use inequalities for that. We have 2 options, this and this. For exclusive, use this option. For inclusive, use this option. This is exclusive, so write exclusive here, and this must be inclusive. This is inclusive, so inclusive is here and this is exclusive. And the first value must be 0 in both conditions. rule, if one is inclusive, the other is always inclusive. If one is inclusive, the other is always exclusive. One is exclusive, other is always inclusive. Now let's practice of these questions to understand these concepts well. Number one, question number 7. First we will cover this one, discrete data. Well, number of pupils means discrete. There are 5,000 schools in a certain country. The cumulative frequency table shows the number of pupils in a school and the corresponding number of schools. Since these upper class boundaries are inclusive, so we will go number one, this data is discrete, and number two, these values are inclusive. So we will write the same number here, 600, 450, 350, 250, 100, and first number must be 1. When these are inclusive, then the first number of the first class interval must be 1. So this is 450 and this is 600. So this number must be 451. This is 350, so this must be 351 because we are making class intervals. And mid values are very simple. Frequencies are frequencies. So when you will subtract these two, you'll get 300. So this 300 should be here. When you will subtract these two, you'll get 600. It should be here. This is the reverse. Frequencies. I'm sorry. So part 1, draw a cumulative frequency graph and estimate median. Graph means either draw a polygon, cumulative frequency polygon, or cumulative frequency curve. Number 1, label the axis, number of pupils, cumulative frequency. If you won't label the axis, you will lose 1 mark. Scale is given, so just follow the given scale and join the corresponding points by means of straight lines. So this is known as the cumulative frequency polygon, because the word graph means either draw polygon, cumulative frequency polygon, or draw cumulative frequency curve. I normally go for cumulative frequency polygon. Now this is 5,000, and just take the half of 5,000 is 2,500, and this will be median. Now 80% of schools have more than n pupils. Estimate the value of n correct to the nearest 10. 80% of the schools, so 80% of 5,000 is 4,000. More than means the upper part of the curve. Whenever you will get this thing more than, this means upper part of the curve, meaning you have to come in this way. So 4,000, count 4,000 in this way. So 4,000 means this. This is the 4,000. And this is the value of n, because this part is required. More than n people. Whenever they say more than, or at least, or minimum, always use this part of the curve. So n is this, 170. Find how many schools have between 201 and 250 inclusive pupils. 250, 201 and 250. 500. Calculate an estimate of the mean. For mean, we basically constructed this table, and you can easily get the mean. Mean is fx, sigma fx over sigma f. That's the answer of the mean. You can evaluate yourself. So we have done question 7, and we went for class intervals because data was discrete, and since this was inclusive, so we wrote the same number here and we had 1 here. We have done this concept. Now we'll do this concept, exclusive. So first number will be 89, and this first number must be 0. Question number 9. See, the data is discrete, and first we have, for this part, we will draw, we will construct a frequency distribution. So first we will do this part. So this number is exclusive, so we must have 99 here. 69, 49, 9, and the first number must be 0 because this is exclusive. When this is exclusive, first is 0. If this was inclusive, then first number would be 1. So 69 means write 70 here, 49 means write 50 here. So these are the class intervals. Get the mid values of these class intervals, and this is the way to get the mean. Now first part, without drawing a graph, show that median for country B is higher than median for country A. So first take the 50% of 300, which is 150. Now look 150 in cumulative frequency. Search 150 here. So 150 is here. So median lies between these two numbers, 20 and 30. 20 and 35. And 150 is here. So median would lie between 50 and 70. So median would lie in this interval and median of A lie in this interval. So median of B must be greater than median of A. Find the number of candidates in country A who scored between 20 and 34. So 20 and 34 means 159 minus 68, 91, and it's here. So we have done both the questions for discrete data. Now continuous. For continuous we have 11, 21, 26, 33. We'll do 2 questions. Number 1, 11. Now this data is continuous, weight in grams, continuous. So you have to go for the inequalities, class boundaries. Since this number is exclusive, so use this inequality, type of inequality. C, 70, 60, 60, 50 and so on, and the first number must be 0. So these are the class boundaries because both the numbers are same. Now you can easily draw the histogram. Get the frequency densities. These are the frequency densities. These are the class widths. These are the frequencies. Frequency density is frequency upon class width. Now you can easily draw the histogram. 2, 3, 10, 12, 5, 1. Here is the histogram. So must label the axis. Frequency density, weights in grams, must write the unit as well, and this is the first bar, second bar, third bar, fourth bar, fifth bar. This horizontal scale is starting from 0.5, negative 0.5. This student took negative 0.5 here, or you can use this thing 0 to 20. Let me correct this. This should be 0 to 20. Well, the first is 20 to 30, first bar. 20, you can write 0 here, you can make the jag. So the first bar is 20 to 30. The next bar is 30 to 40. Sorry. The next one is 40 to 45. Then I guess 50. Then 50 to 60. And then 60 to 70. Next part. State which interval the median weight lies. This is so simple. Take the 100, take the 50% of 220. So which is 110. So median would lie between 45 and 50. Find the smallest possible value and the largest possible value for the interquartile range. First get the interval for Q1 and then Q3. The interval for Q1 is Q1 is 55th observation. So the interval of Q1 will be 45 to 40 to 45. And this is the interval for Q1. 40 to 45. And the interval for Q3 is Q3 must be, I think this should be the interval 50 to 60. Now they are saying find the smallest possible difference. So the smallest possible difference would be this 50 to 45. Smallest possible value in the smallest possible and largest possible. Let me write this in this way. Q1 lies in this interval 40 to 45 and Q3 lies in this interval 50 to 60. This is the smallest possible difference sorry, and this is the largest possible difference 5 and 20. Next part, how many sausages weighed between 50 and 60? Just take this difference 210 minus 160, which is 50. I'm sorry. Now the next question of this type is 21. See, the data is continuous, weights, measurable quantity. Cumulative frequency is simple, 40 to 90. So this is simple, you can draw this directly. Make sure you write 0 here. And this scale is starting from 40. Now estimate the median. You all know how to estimate the median. No, they are not asking about median. They are asking 64 people weight more than C. Again, they are saying more. So you have to go in this way. The total is 144. So 144 minus 64. You will reach here, 80. So this is the number because this part is required. Let me write this here. 144 minus 64 is 80. Now get the corresponding value of 80. Whenever they say more than, then always subtract the number from total and get the corresponding value. Mean and standard deviation. See, this is measurable. So inequality would be like this. This is similar to question number 11. And the first number should be 0. And mid values are here. This is the formula for mean, sigma fx over sigma f, and for variance use this formula, sigma fx square over sigma f minus square of mean. You can do this yourself. Now the next question is 26 of this type. Again the data is continuous, time. Again go for the inequalities. And the first number should be 0. And get the mean and variance. State how many athletes ran 100 meters in a time between 10.5 to 11.0. So 6 athletes. Histogram, use this table and frequency densities. These are the frequency densities, mean and variance. This is the histogram. You must label the axis. We have done almost all types of questions of histogram, and now question number 8. Well, histogram and CF graph, they both represent continuous data. Number 1, draw cumulative frequency graph. We have class intervals, so first we need class boundaries for that. Get the class boundaries, get the cumulative frequencies. For cumulative frequency, copy the first frequency and then add this frequency into this. So 10 plus 32 makes 42, 42 plus 62 makes 104, and so on. This number must be same as this number. Now draw the cumulative frequency, 0.5 to 20.5. You can start the scale from 0.5, and this is the cumulative frequency. Label the axes. Over 30 rooms. Again, they are asking over. So over 30 rooms. So this is 30. So over 30 room means this. So this is 24. So total is 200. 200 minus 24. 176. So at most means the lower part of the graph. Over, at least, minimum, more than means upper part of the graph, and this means the lower part of the graph. On 75% of the days, n rooms were occupied. 75% of the days, there are 200 days. So 150 days. So 150. Check its corresponding value, it's 60. So 60 rooms. Question number 10. First, arrange this data in ascending order. These are the marks for history exam, and these are for the physics exam. Write this in ascending order, get the median, Q1, Q3 maximum marks, because you have to draw the box plot. So here are the box plots. Physics, this distance is 3 centimeter and this is 6 centimeter. See, median is same, but more variation in physics marks than in history marks because of greater range. Physics marks are more spread out than history marks because of larger range or larger IQR. This is the difference. We have done this question. 12. I think, okay, we have to do this sum. I thought I already have done this question, but I have to do this. We haven't done this before. The cumulative frequency graph shows the annual salaries in thousands. This is the scale of euros of a random sample of 500 adults with jobs in France. It has been plotted using group data. You may assume that this lowest salary is 5,000 here and highest salary is 80,000. Draw a box plot. So for box plot, we need 5 important informations like minimum, maximum observations, and Q1 and median and Q3. So minimum, maximum, median, Q1, Q3. For median, take the half of this, 250. This is median. For Q1, take the half of 250, 125. This is Q1. For Q3, take the half of these two, 375. This is Q3. This is the box plot, and this box shows positively skewed distribution. Salary in 1,000 euros. This is the positively skewed because median is close to Q1 and we have long stretched tails towards the higher values. This means most people earn less than 26,000. This is Q3, 26,000. So the bulk is here, the bulk of the distribution is here. So most people earn less than 26,000, or very few people earn higher salaries. You can say in this way as well. Comment on the salaries. So most people earn less than 26,000, or you can say very few people earn high salaries. We already have done outlier. I told you this is the way to get the lower boundary of outlier, Q1 minus 1.5 IQR, and Q3 plus 1.5 IQR will give you the upper boundary. It's mentioned here. So how high must a salary be in order to be classified as an outlier? So first check the upper boundary. The upper boundary is 42,500. So to be called an outlier, our salary must be greater or equal to 42,500. Must be greater than. to be on a safe side. Next, show that none of the salaries is low enough to be classified as an outlier. Check the lower boundary. Since lower boundary is negative and salaries cannot be negative, so no salary is low enough to be an outlier. If you want to take the screenshot of this solution, you can. I think we have done this question. We haven't, I guess. Question 13. The lengths of the diagonals in meters of 9 most popular flat screen TVs and 9 most popular conventional TVs are shown below. Represent this information on a back-to-back stem plot. Flat here, conventional here. Just ignore the decimals. Consider this number as 76. Check the lowest number. It's 0.65, I guess. 0.65, and the highest number is 1.07. So write 6, 7, 8, 9, 10. Then this is 5, 7, 9. You know how to draw this. Must mention the key. Either write this number or this number. 671 means 0.76 means, this means 0.76 meter of flat screen TVs, and this means 0.71 meter of conventional TVs, and get the median and etc. and get interquartile range and mean and standard deviation. These are the formulas, sigma x over n, and this is the way to get standard deviation. You must watch my lecture on measure of central tendency and averages. I already have discussed these things in detail in that lecture. I'm leaving this question. This question is important. Ashfaq and Kuljit have done a school statistics project on the prices of a particular model of headphones for MP3 players. Ashfaq collected prices from 21 shops. This data is small, so he should go for this data would be considered as ungrouped data. Kuljit used the internet to collect prices from 160. This data is large, so this data could be considered as would be considered as the group data. So this is the ungrouped data. For ungrouped data, the suitable diagram is stem plot and box plot. And for this data, since this is group data, large data, therefore group data, therefore the suitable diagram would be histogram or cumulative frequency. Name a suitable statistical diagram for Ashfaq. Stem and leaf diagram, because lesser number of data items. Or you can even write box plot because of lesser number of items. Histogram, because her data contains a large number of items. You can even write cumulative frequency graph instead of histogram. You can write anyone from both. This question is important because we have to scale this these observations 100, nearest 100. I mean, scale $100, like this. So just ignore the hundreds, 2 zeros, and write the numbers without hundreds, and then draw this time plot. And read this as 14/3 means 14300, because this is a scale. And you all know how to get the lower quartile. Probability. 3 different caravans in the showroom are chosen at random and their prices are noted. Find the probability that the 2 of these prices are more than the median and 1 is less than the lower quartile. This is so simple. Lower quartile is this. So below this we have 2 observations, I guess, this and this. And median, this is 11, so 6 observation would be median. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5. There are 5 observations which are greater than median. So 2 observations are greater than median means 5 upon 11, 4 upon 10, and 1 observation is less than Q1 means 2 upon 9. And this is compulsory because this is random. You all can understand this easily because you already have done probability. Now I will take the important questions only. Again, this is scaled. See, 23. This 22 means 20 and this 2 means 22 double zero. So double zeros were scaled. We already have done this question. Advantages of give one disadvantage of using box whisker plot rather than a stem plot. Box and whisker plot does not show all the data items, whereas stem and leaf diagram retains all the original data. This is the best advantage of stem plot. It retains all the data. It shows all the data. An expensive house is defined as the house which has a price that is more than 1.5 above the upper quartile. So the upper boundary is this 945. So there are two houses, expensive houses. Give the prices of the expensive houses. These are the prices of the two expensive houses. Give two reasons why this is not a correct histogram. Because frequency used on y-axis instead of frequency density. The first wrong thing on this histogram, and the second wrong thing is bars are not joined. Bars are not touching, data not continuous. This is enough, and I hope this lecture will help you to understand how to solve the questions of representation of data. I'm going to finish this lecture here. So this is all. Anyway, this is the last question, and after this we will finish this lecture. A group of children played a computer game which measured their time in seconds to perform a certain task. A summary of the times taken by girls and boys in the group is shown below. Box plot. So here are the box plots. Time in second. More variation in boys' time than in girls' times, and girls' times are shorter than boys' times. On average, girls measure shorter times than boys. Girls are faster. More variation in the times taken by boys than girls because of the higher range. An important advice for me and for everyone: be good to others. Good luck and Allah Hafiz.